Air forces fly and fight from air bases. However, it is at the air base that air power is most vulnerable. Air bases can be the most immediate and lucrative target for an adversary because it is far more effective to destroy aircraft while they are on the ground rather than to hunt them in the air. Destroy the infrastructure that supports the aircraft, and you essentially destroy air operations. Not only must the United States maintain the capability to recover our own air bases after an enemy attack, but must also be capable of restoring an enemy airfield after U.S. seizure. In either scenario, proper preparation must be accomplished prior to the moment of need. Time will not be available during the conflict to accomplish meaningful training. Airfield damage repair encompasses more than just pavement repair. Damage assessment, explosive ordnance reconnaissance, MOS selection, repair quality criteria, aircraft arresting system, and utility system repairs are just a few of the areas that must also be considered. Specifically, in this lesson, we will address airfield pavement repairs and methods. In this lesson, you will learn about different crushed stone repair methods, equipment for repair, the crater repair convoy, and the 12-step crater repair procedure. Let's get started. Damage to airfield pavement surfaces can be summarized in two categories, which are classified as spalls and craters. Spall damage should be expected after any conventional airfield attack. Spalls are generally defined as pavement surface damage that does not penetrate through the pavement surface to the underlying layers and may be up to 5 feet in diameter. Craters represent damage that penetrate through the pavement surface until the underlying base and subgrade soil, which uplifts the surrounding pavement and ejects base, sub-base soils, rock, and pavement debris around the impact area. Craters represent much more severe damage than spalls. Large craters have an apparent diameter equal to or greater than 20 feet. Small craters have an apparent diameter less than 20 feet. There are 3 crushed stone repair methods being used today. These are the debris backfill, choke ballast over debris, and the choke ballast repair method. Each repair method is used for a specific type or crater condition. While the initial fill material differs for each repair, the final 18 inches of the repair is the same. We will cover how each crater is initially filled, then look at how all the repairs are capped. Debris backfill crater. Used when subsurface debris is plentiful and suitable for filling the crater. Fill the crater with debris up to 18 inches below the surface. Fill the remaining portion of the crater with crushed stone. Choke ballast over debris crater. Used when subsurface debris is suitable for fill but limited. Fill the crater with usable debris. Continue to fill the crater up to 18 inches below the surface with ballast rock and fill the remaining portion of the crater with crushed stone. Choke ballast repair. Used when water is standing in the crater or if subsurface material is unsuitable for filling the crater. Fill the crater with ballast rock up to 18 inches below the pavement surface. Fill the remaining portion of the crater with crushed stone. Let's look at some of the UTCs required to accomplish a crushed stone repair. UTC 4FW-FD, FOD vehicles. UTC 4FW-CR, crater repair vehicles and equipment. When traveling to the repair sites, haul route clearance is the priority of the crater repair operation. All front-end loader and grader operators should assist by traveling to the crater site with buckets and blades down in areas where debris is present. Where the debris is heavy, front-end loaders should move debris to the side of the haul route, trying not to leave a thick, compacted layer, which could be too deep for graders to remove. Your convoy should travel the speed of the slowest equipment. You should stagger equipment on alternative sides of the haul route and space equipment to limit secondary damage. A good rule of thumb is 100 feet apart. Ensure blades and buckets overlap to clear a wide enough path for heavy equipment. The crater chief determines the repair method, location of stockpile, debris pile, and mat assembly areas, while ensuring the repairs progress smoothly and rapidly and that no equipment stands idle. Your crater chief does not have to be the highest ranking person, but must know the steps and be able to solve problems and make decisions quickly. Now let's dive into the 12 steps for the crater repair procedures. Step 1. Determine repair method and UXO sweep. Stop 50 feet from the edge of the crater or at first sign of large debris. Front end loader operators dismount and flank the left and right sides of the crater, while the crater chief walks to the center of the crater. If no additional UXOs are found, the operators will return to their front end loaders while the crater chief determines the repair method. If suitable debris is plentiful and suitable for filling the crater, use the debris backfill crater repair method. If subsurface debris is suitable for filling the crater, but debris is limited, use choke ballast over debris crater repair method. If water is standing in the bottom of the crater, or if subsurface material is unsuitable for filling the crater, use choke ballast crater repair method. The crater chief will also select locations for both the fill material stockpile and debris pile no closer than 30 feet from the crater. The crater chief will select a FOD cover assembly 100 feet away on the crater. Step 2. Initial clearing. Using the front end loader, clear the debris approximately 20 feet away from the crater. Start at the crater's edge and work outward in a circular motion. Using the grader and tractor-mounted kick broom, clear the stockpile and FOD cover assembly area previously determined by the crater chief. Step 3. Initial crater profile measurement. Move stanchions to the opposite side of the crater, aligned along the center line of the crater. Place stanchions approximately 10 paces from the apparent start of the upheaval, parallel with aircraft traffic. Level the aluminum siding planes on top of each stanchion by centering the bubble in the level. Start measurements on obvious upheaval, moving away from the crater towards stanchions. Place rod between stanchion with single target out. Sight the target along the upper edge of both stanchions by standing approximately 2 paces behind stanchions. Move the rod along line of sight between stanchions. Keep the rod plump and place on the pavement every 2 to 3 feet. The upheaval starting point has been reached when the single target drops below the line of sight across the top of the 2 siding planes on stanchions. Clean the pavement and mark a spot 2 feet further out from the rod, away from the crater. Position both stanchions approximately 2 paces to the left or right of the crater, parallel to the original line of sight. Note: mark one complete side of the crater before moving to the other side of the crater. Step 4. Remove upheaval, excavate, and backfill. Debris backfill crater repair method. Using the excavator, break and remove the pavement in the crater bottom that exceeds 3 feet in diameter. Using the excavator bucket or moil point, begin breaking and removing the upheaved pavement to mark upheaval limits. Note: if the crater conditions permit, use the front end loader or dozer to enter the crater and assist the excavator in removing upheaval. Push ejecta and the upheaval less than 3 feet in diameter into the crater, leaving a minimum of 18 inches below the crater lip for crushed stone repair. Using the excavator moil point, break up the upheaved pavement, not removable using the excavator bucket, or by its removal will cause the crater to become too large. Push the unusable debris to at least 30 feet off the MOS and pile no higher than 3 feet. Choke ballast over debris crater repair method. Using the excavator, break and remove pavement in the crater bottom that exceed 3 feet in diameter. Using the excavator bucket or moil point, begin breaking and removing upheaved pavement to marked upheaval limits. Note, if the crater conditions permit, use the front end loader or dozer to enter the crater and assist the excavator in removing upheaval. Push the ejecta and upheaval less than 3 feet in diameter into the crater, leaving a minimum of 18 inches below the crater lip for crushed stone repair. Break up upheaved pavement, not removable, using the excavator bucket, whereby its removal will cause the crater to become too large. Push unusable debris to at least 30 feet off the MOS and pile no higher than 3 feet. Continue to partially fill the crater with 1.5 to 2.5 inch ballast rock, leaving a minimum of 18 inches below the crater lip for crushed stone. Choke ballast crater repair method. If possible, pump water out of the crater or excavate the crater clean. Using the excavator bucket or moil point, begin breaking and removing upheaved pavement to marked upheaval limits. Note, if the crater conditions permit, use the front end loader or dozer to enter the crater and assist the excavator in removing upheaval. Using the excavator moil point, break up upheaved pavement, not removable, using the excavator bucket, or by its removal would cause the crater to become too large. Push unusable debris to at least 30 feet off the MOS and pile no higher than 3 feet. If available, geotextile fabric may be used to line the crater to prevent ballast rock from sinking to the bottom of the crater. Continue to partially fill the crater with 1.5 to 2.5 inch ballast rock, leaving a minimum of 18 inches below the crater lip for crushed stone. Step 5. Intermediate crater profile measurement. Set up stanchions on each side of the crater, parallel to aircraft traffic, and across points to be checked. Place the rod with the single target up on the lip of the crater. Sight across sighting planes of stanchions using the method previously established. Note, upheaval has been sufficiently removed if the rod's triangle target falls below the stanchion line of sight. If additional upheaval is discovered, remove using the method previously established. Check additional points around the crater or as upheaval is removed. Step 6. 18-inch edge cuts and leveling fill material. Make the top 18 inches of the crater side as close to vertical as possible by using the excavator bucket, front end loader, or shovels. Materials cut from the crater's edge can be carried across the crater and leveled a minimum of 18 inches below the crater's lip. Note, if ballast rock was used as fill material, geotextile may be placed over ballast rock. Step 7. Overfill and compact crater. Place crushed stone material in the crater in lifts approximately 7 inches thick. Compact each lift of crushed stone using a minimum of 2 passes of a 10-ton vibratory roller, 4 passes of a 5-ton vibratory roller. If a vibratory roller is not available, use an excavator compaction plate at a rate of 1/2 foot per second. Now let's look at the remaining lifts. Note, The last lift should overfill the crater by approximately 3 inches above the original pavement surface height. During this finale process, backfill operations should be performed parallel to the center line of the airfield surface. Step 8. Final grade and compaction. Grade the compacted crushed stone to approximately 1 inch above the pavement surface. Compact the crushed stone flush with the pavement surface using 1 additional pass of a 10-ton vibratory roller, 2 passes of a 5-ton vibratory roller. If a vibratory roller is not available, use an excavator compaction plate at a rate of 1/2 foot per second. Step 9. Dynamic cone pentrometer. The dynamic cone pentrometer, or DCP, is used to determine the California bearing ratio, or CBR value of the soil. The CBR test is a way of putting a figure on this inherent strength. The DCP is used to determine this value. The DCP measures a soil's bearing capacity and shearing resistance. Tests must be conducted after the crater has been filled and compacted. When installing an FRP FOD cover, a minimum CBR of 25 must be achieved. If not installing a FOD cover, minimum aircraft-specific compaction requirements must be achieved. C-130 CBR greater than 15, C-17 CBR greater than 25. Step 10. Check repair quality criteria. Place the single target end of the target on the repaired surface. Adjust the rod's movable twin triangular targets so the horizontal edge of the lower target is 1/2 inch below the 0 point on the rod, and the horizontal edge of the upper target is 1 inch above the 0 point on the rod. Set up the stanchions as described during the crater profile measurement step. Measure across the repair in 2 to 3 foot increments along at least 5 parallel lines. Note, if 3 or more consecutive line of sight measurements fall outside the target gap, but no farther than 1/4 inch, or if one measurement falls more than 1/4 inch outside the gap, the repair exceeds flush criteria. Step 11. Sweep. Using the tractor with broom, sweep to remove loose material that could get under the FOD cover when it is towed over the crater. Sweep material away from the crater. Do not sweep loose rocks onto the compacted stone. Step 12. FOD cover installation. Hand sweep 2 feet from the crater edge for sweeper clearance, making sure not to drive or sweep debris into the crater. Once cleared, the mat assembly team will begin installation of the FOD cover for the completed crater repair. Installation requires a minimum of 8 personnel and is recommended the crew lead be a structural specialist. This assembly can be done directly on the crater, or if adequate personnel are available, the mat can be assembled during the crater repair process and then dragged across the repair as demonstrated. This concludes the 12 steps for the crater repair procedures. The 2 other crushed stone repairs that may be required to accomplish the regeneration of aircraft sorties are the wet crater and small crater repair. Remember, when performing these steps, to place safety first. Teams should not rush and do not take chances, especially when working in inclement weather. Be aware of radio and aircraft traffic. Watch for personnel on the ground and ensure the proper PPE and clothing. Airfield damage repair is a complex program to expeditiously restore aircraft launch and recovery surfaces following an enemy attack. Following the procedures outlined in this training will help ensure a smooth aircraft operating surface, allowing for mission continuation. Congratulations, you have completed this lesson. In this lesson, you learned about crushed stone repair methods, equipment for repair, the crater repair convoy, and the 12-step crater repair procedure. For additional information, visit the AFCEC Expeditionary Engineering homepage.